Welcome, my name is Marcel. I'm the author of the Mockifer library. This tutorial is to talk about how the routing system works in Mockifer and run through some examples of it. The routing system is actually pretty much the heart of how Mockifer works. So one of the best ways to see how it works is by using the editor. So you know that you can run the editor from this shell script, which really just starts a Gradle task. And this is the editor that we've seen in previous tutorials. And on the left-hand side, there's a section for all registered routes. And if we select one, we see the detail of it on the right-hand side. So the first thing I'm going to do is explain what these routes are, and then what all these fields do. And then we'll go through an example of how we can create some brand new ones and see how they work. So in Mockifer, whenever a request comes in, there must be some registered route of some kind set up that is configured so it can pick up that request and react to it. If there's no route registered that has the criteria that would match it to a request, then you'll basically get a 404 error. It won't be able to find any way to respond to a request. The editor program here is typically how you create and delete and edit these routes. And what actually happens is all these routes in this list here get saved into a JSON file, and I'll just show you that now. So underneath the content folder, which is packaged for every platform, there's a routes.json. I'll just open that up. And if we look for that one we were checking, which was the get all cats, that's pretty much its representation here. And it's really just the different properties that you can also edit within the editor itself. So it's highly recommended you use the editor to create, delete, and save routes. This routes.json file gets regenerated every time something is changed in the editor, so you don't need to and probably shouldn't manually edit this file because it will get regenerated. Originally, when I was developing this project, I was going to save all these routes in a SQLite database, and I actually had it all working that way, and it worked great. But what I kind of realized was that if you have teams of people all working on the same instance of Mockifer under version control, SQLite was a really bad choice when it comes to merge conflicts, because it's effectively a binary file. And I know there's some hacks for Git to try and help that situation, but instead I decided that it should all just be saved in a flat file. So that's how I've done it. And that way, if you have a Git conflict with someone else, you're just dealing with text and very readable text, so it's not hidden behind a binary file. So you don't really need to open that routes file very often, really just if you have a conflict of some kind or you just want to check. So the editor is where all the action happens. So we'll walk through this particular route here. I might just expand this window so we can see it a bit better. So here I've chosen this request route here for cats.getAllCats. So over here we can see a route must have an ID. Now the ID is unique amongst all routes. So it's kind of globally unique within the instance of Mockifer. That's because it's used to find that route in different scenarios. The next setting here is called route is internal, which means always enabled. And what that really means is if I've got cats.getAllCats, if I call a GET request with cats as the URI, it's always going to map to this route and do whatever this route says. There are other ones that you can have a look at in here that are not internal. So if I go to, for example, where's one that's not internal? These guys, okay. So this one here, it's not internal, which means that this will never ever get triggered unless something pushes the mock first. And I'll get onto the topic of pushing mocks in a little bit, but I'll leave that bit for now. So coming back to our cats. If a route is internal, you can't push it because it's just always activated. It's never really going to be in a state where it's not activated. Display name is pretty self-explanatory, and description as well. The request method. So the request method is just your typical get, put, post, delete, and that's one of the first things that gets filtered when it's trying to match a route to a request. The URI actually represents a regex expression. So in this case, it's going to match if the URI is /cats. But if I jump over to perhaps getting a cat details, so in this case, you would call /cats/ and then this here is a little bit of regex, which says pretty much everything except a / and at least one character. So if I was to look at my Postman scripts, cat details has /cats/ ID1, so that would match that route. Whereas a regular cats URI doesn't do that. Route override. This is kind of a special case. So what I can show you here is a quick example of it without getting too far into detail. So here I've got a simulated error. So I've created this route that whenever it's in use, it will deliberately pretend to be an error. And what it will do is it says, my route override is cats.getAllCats. So if this route is running, if it's activated, which is done by pushing, and I'll just do that now quickly without getting too far. You can see here, it's now an active route. Anytime a request comes in that ends up resolving to cats.getAllCats, which is actually the one we were just looking at before, instead of it running that route here, this one will intercept it and kind of hijack it and take over. And I'll just quickly give you an example of what happens. So I've pushed this mock route, which means that it's sitting there waiting to be picked up, ready to intercept. So if I open up Postman and I do a /cats, even though we have a route for cats.getAllCats, which is what it would normally map to, when I run it, it's actually going to resolve to using this mock route instead. And when it uses it, what happens is it will consume it. So that's the way that mock routes work. So if I run this now, you can see here that instead of getting a list of cats, I got an error message back. This was a fake error generated by mock. You also notice over here in this section that active mock that was there before, even though I had pushed it, because it's now been consumed by something, it's gone again. So if I call cats again a second time, and this time there's no override waiting to intercept it, it's reverted back to the original mapping again. And down here you can see that's the response text that we saw, and that's why we got a 500 error, because it was simulating that condition. But that's kind of what route overrides can be used for. They can be used for other things too. So I'll come back to our original one. Query string contains. So this is saying that if there's a query string on a request, and we put some sort of value in here, it will examine what's in the query string, and if it finds that value anywhere in that query string, it will match. Similarly, the query string equals is quite the same idea, except that it has to be an exact equal. It won't work if it's just a contains. So I do actually, do I have an example of this one? Maybe I don't. In any case, that's how that bit works. When we come down to this section here, this is where things get a little more interesting. So Mockifer can be a little bit clever in that if we do a request that sends up a request body, which you would normally have with, say, a post or a put, you can actually ask it to have a look in the incoming JSON request body for something at a certain JSON path, and then validate whether it contains value or equals a value. So I do have some examples of this. Here's a basic example. So we've got a route here that says when a post is done to this URI, and in addition to that, the request body that we expect to be JSON can resolve to finding a path to test and then name, and the value at that name element contains the word Bob, then we're going to return this. So here's an example in Postman where I've wired that up. So you can see here we're calling the URI correctly with a post, and this is the request body we're about to send up. Test name Bob, and we kind of said that if the request body contains a path that can find the value, a node called test and a node called name, and then it also contains the word Bob, it would match. So if I run this request now, it has returned this response because it found a match. If I do this, so if I said that's the data, and I'll rerun it, it has not found a match because test name doesn't contain Bob. It's now Bob or whatever I've just written. Put it back to Bob, and it's refound a match again. Now, the equals works exactly the same way, except that that value, instead of a contains check, it performs an equals check. So it has to be exact equals. So it becomes fairly powerful because it allows you to examine dynamically the content of a request body, looking for a particular value. And there's one variant on that, which I've got a test route for here, which is almost the same setup all the way through. Test JSON path array. This time we're saying, I want you to look for something in the request body, test one name. And the one is important. So when Mockifer is crawling through this path, if it finds a number, it assumes that you're trying to find an element in a JSON array. So again, I've got a Postman example of that. So here we're calling correct URI, but the request body this time we've got test, which resolves to that first element, but then we've got an array. And we're saying we want to look in the array index of 1, which would be 0, 1, for a property called name, which would be this name, and it should contain Bob, which is Bob. So I run this, we found Bob at element 1 of the test array in the request body. Of course, I could make it fail by making that value not match, or various other things. I could have it so there isn't even a first element, or element at position 1 on a zero-based index, and a variety of things like that. But that's how the JSON pathing works. So I'll come back to my original example again. So next thing you can do is, if you choose to, you can hard code what sort of status code to return for the request. And if you look at that error one we had before, it's going to say, I'm going to actually return a status code of 500. And that's, in this case, how you would simulate an error. This one here, response delay milliseconds. So I've got example one here. So in this one, when we talk to this URI through a GET, it's going to wait 200 milliseconds before responding to kind of simulate a lag. So just open this up a little bit further. Now I don't think I actually made a demo for this, but we could perhaps try it out now. So I can grab that. And let's just change this to a GET. Test simulate delay. And then we'll send this. Now, it probably wasn't obvious because it was only 200 millis, but you can see it responded. If I go over here and I change this to, say, 2000 millis, which would be 2 seconds, I can save this route. And the cool thing about Mockifer is, as you save routes, it's actually dynamic. So I don't have to restart anything. I can come back in here and have an extra slash there. Seems to cope still. So if I run this now, there's going to be a 2-second lag before I see a response. There you go. That was about 2 seconds. And so that's how you can actually make specific requests kind of simulate a laggy response if you want. Routes by default don't have a delay because normally we want them to run as fast as we can, but you can actually force that. And there's also a Mockifer API directly that you can set at a global level for the whole server. So every request has a certain delay. That's a good way to test timeouts or just what happens when things are a bit laggy. And hopefully that was also a good example of where I just edited a route while the server was still running, and I didn't have to restart the server. It's just dynamically picked it up. Okay. The other example, which is the one down here, is when we want to get all the cats. This controller ID is an ID that the JavaScript engine that's running underneath kind of knows about this ID, and it knows how to map that to a piece of code. I'm not going to go into that in this tutorial, probably the next one, but when we say this, what it's saying is the request matches to this route, but then we delegate handling of that route down into the JavaScript application instead of at this level. And this bottom section here, normally if you have a controller ID, you wouldn't respond with a blob of JSON, but I'll just show you one that we were looking at before. So for example, we had this get a fake list of cats, and it doesn't call an internal controller ID. All it does is actually return a blob of JSON here. And the place where that's stored, if you look in the JS folder, there's a data folder and there's a mocks folder. And if we're looking at this one, the fake list of cats, here it is here. So the route ID is mocks.cats.getFakeCats. And because they're unique, there will be a file with exactly the same name in here. And if you open that, that's actually what I've pasted into the editor there. But you can edit this directly in here. And so that's how that bit works. So let's try to create a brand new route, and let's say we want to fetch a list of dogs. So just pretending over here we want to say we want to make an endpoint that if you call /dogs, I'll return a list of dogs. Now of course when I call it now, we don't get a result because there's no route yet that has any idea about a GET request for /dogs. So we'll come up here and we'll create a brand new one. So I'll create a new route. We might go dogs.getAllDogs, and we'll turn it to internal, which means it's always activated. We don't have to push this thing. Give it a short name, get all dogs, bit of a description, get all the dogs in the universe that is known to us. And what sort of method should we look for? And we'll just go with a get for now, and we'll just keep it simple with we want cats, we want dogs. There we go. And for now we won't put any extra filters, that's probably good enough. And then we can say, okay, well when that happens I'm going to return a status code of 200 and then some sort of body text. So I've got some little bit of JSON here that I had written earlier to save time. I can just put that in here. So if I call this, you can see there it's telling you what file it's going to save it as. So if I call this request, this is the body response we should get back. Okay, so I can save that route. There it is, you can see it's appeared in our list. We'll go back to Postman and retry the same thing. There you go. So it's resolved dogs to being this data with Rover and Spot and Monster. So that's how to create a basic route. I'll just go over the detail around how to create one of these non-internal routes and how you'd push it, which is similar to this mock cats one, but we'll create a brand new one. So let's say we want to intercept a request to get all the dogs and send back some fake dogs instead. So let's change this text here to Mocky Dog 1 and 2 and 3, for example. And just come back over here, we'll create a new route. And this time we'll say mocks. Now the naming convention is completely up to you. There's no prescribed naming convention in Mockifer. You have to use lowercase and a couple of special characters when choosing a route ID, which the editor enforces. But if you're manually editing a JSON file, just be aware, don't, well, if you break it, it's your fault, I guess. So we're going to say mocks.dogs.getAllDogs. Mock dogs, mocky dogs, clicks. And we're going to say a get. Now at this point I could do a route override, but we'll just do a normal one where we say /dogs. And you see it kind of matches up in the same way as the original dogs one does. But come down here and we'll put our mock dogs in instead. And let's say we have 200. There we go. And in this case, for the mock dog ones, we're not going to go with an internal. It's going to be a mock. You can't push it yet because we haven't saved, but as soon as I save it, and I might just reselect it over here, you can see that this is it here. If I go back to Postman, call dogs again, you know, we're still getting Rover, Spot, and Monster, but if I push this mock, what should happen is it will look in the list of active mocks first before looking in the regular internal routes. So if I hit this now, there we go. It's picked up that mock, which will disappear in a second because it's been consumed. There it goes, it's gone. And we've got Mocky Dog 1, 2, and 3. If I call it again, back to the original again. And so the purpose of this is that we can set up a bunch of routes that can be pushed on demand, and you can push many of them, or you push the same one many times. So if I push this guy twice, see there's 2 instances, and hop back to Postman, we're going to get the Mocky Dog response the first time, and then this will update in just a second. There you go. Do it again. We're still getting the Mocky Dog stuff coming back. Yeah, there it goes. And then the third time, because we have consumed all those mock routes, we're back to the basic ones again. And this becomes very powerful when you're doing mocking for automation, where you want to set up a test or a test suite with a certain series of mocks that should take over to simulate a specific condition. That's probably all there is to show in terms of how the routing system works. Have a play around with it, get familiar with it. These filters can be powerful, especially the JSON one. If you're interested in how this code works, you're welcome to look in the server.cpp C++ code. That's where it actually does all the parsing, and actually it might be the routes manager in there, now that I think of it. And that's all for this tutorial. In the next tutorial I'm going to talk about how to implement the JavaScript application code that you would do if you were going to use controller IDs instead of just pre-baked canned responses, because sometimes we want things to actually maintain state inside the mock server, which of course you can reset at any time like that. And just by the way, if you have pushed mocks in here, Mockifer has a clear all active mocks function, which you can get rid of them all, which can be called through code as well. So that's probably enough for this tutorial, and the next tutorial we'll look at how to do the actual JavaScript application side of setting up routes. Thank you.